Amazon SageMaker is a cloud machine learning platform that was launched in November 2017. SageMaker enables developers to create, train, and deploy machine learning models in the cloud. SageMaker also enables developers to deploy ML models on embedded systems and edge devices. Hi everyone, this is Kavya from Edureka. Welcome to today's session on how to deploy a machine learning model on Amazon SageMaker. Before we begin today's session, I'd like to address the agenda. Firstly, we will understand what is Amazon SageMaker, and then we'll create your very own Amazon Web Services account. Then moving on, we will create your first notebook instance. Then finally, we will download and explore Dataset, train your model, deploy your model, and then finally evaluate your model. We'll conclude this session with a case study. Kindly take up this time to subscribe to us and do not forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, to learn more about new trending technologies, visit our page, the link to which is given in the description box below. So, without much ado, let's get started. What is Amazon SageMaker? Amazon SageMaker is a cloud machine learning platform that enables developers to build, train, and deploy ML models very quickly. It is basically a service that enables a developer to build and train machine learning models for predictive or analytical applications in the Amazon Web Services public cloud. Now, you know that data science and machine learning models are in demand right now. So, Amazon SageMaker is here to help you. Machine learning offers a variety of benefits for enterprises, such as advanced analytics for customer data or even back-end security threat detection, but it can be hard for IT professionals to deploy these models without prior expertise. So here is where Amazon SageMaker comes. Amazon SageMaker aims to address this challenge as it provides built-in and common machine learning algorithms along with other tools to simplify and accelerate the entire process. Amazon SageMaker supports Jupyter Notebooks, which are open source web applications that help developers share live code. Now, for SageMaker users, these notebooks include drivers, packages, and libraries for common deep learning platforms and frameworks. A developer can launch a pre-built notebook, which AWS supplies for a variety of applications and use cases, then customize it according to the datasets and schema the developer wants to train. Developers can also obviously use custom-built algorithms written in one of the supported ML frameworks or any code that has been packaged as a Docker container image. SageMaker can basically pull data from Amazon Simple Storage Service that we'll be addressing later on in the session, and there is obviously no practical limit to the size of the data set here. So to get started, a developer logs into the SageMaker console and launches a notebook instance. SageMaker here provides a variety of built-in algorithms such as linear regression, image classification, or the developer can import his or her own algorithm. Then, when the developer is ready to train the model, he or she specifies the location of the data in S3 and the preferred instance type, and then eventually initiates the training process. SageMaker uses automatic model tuning to find the set of parameters, also called as hyperparameters, that best optimizes the algorithm. When the model is finally ready to deploy, the service automatically operates and scales cloud infrastructure using a set of SageMaker instance types that includes several with GPU accelerators and that have been optimized for ML workloads. SageMaker deploys across multiple availability zones, performs health checks, applies security patches, sets up auto-scaling, and establishes secure HTTPS endpoints to connect to an application. A developer can then track and trigger alarms for changes in production performance via Amazon CloudWatch metrics. Now that we know what is Amazon SageMaker and how the entire workflow really works in SageMaker, let's move on to the next part of the session and learn how to create your own AWS account. So I'm just going to go to my local web browser and I'm just going to Google for AWS. I'm just going to click the first link, which will redirect me to the official website of Amazon Web Services. And as you can see here, there's a navigation on top that will allow me to check the different and various products that Amazon, offer to us. There are Amazon EC2, there's Amazon Simple Storage Service, that is S3. We'll be using this later on in the session. There are different solutions, there's pricing of all of the products that Amazon provide to their customers. There are also events that happen in AWS that you can participate or be a part of. And if you scroll down, you can see the solutions that Amazon provide in the form of icons, and this is just a summary of all of what they really do. So this is not really necessary for you to know right now. We're just going to create an account. So what I'm going to do is I'm just going to click on to sign into the console. And as you can see that this will redirect me to a sign in page. If you already have an account, that's great. You can just, type in your username and you can type in your password and then just log into your account. Else you will have to create a new AWS account. You can see that option right in the bottom. And once you click that, you will be redirected to a page where you'll have to provide some credentials like your email address, your password, confirm password, AWS account name. You will have a lot of steps that you'll have to go through. You'll have to give in your card details, your debit card or credit card details for this. You can also read the rules and regulations of their free tier account. They have some instances and products that they provide for some free amount. So you will have to read all of that, just get an overall idea of how Amazon provides its services and what is free. So you can really maximize the use of their free services, right? So once that is done, you can just sign in to your existing AWS account. That's what I'm going to do. So once that is done, we'll meet on the other side. So this is what you will be able to see when you log in. You'll just be able to see your AWS management console. You can explore AWS. You can also build a solution. You can learn how to build, and you can see the recent services that you've been working on. You can also view all of the services that are currently present in Amazon Web Services. And with all of that said, let's go ahead and create your first notebook instance. So as you can see on the top, there is a navigation search bar. Here you can just look for Amazon SageMaker. Okay, and then you just click on the first service that pops up. And this will redirect you to your Amazon SageMaker. On the left-hand side, you can see you have your Amazon SageMaker Studio, dashboard, search images, ground truth, notebook, processing, training, inference, and Edge Manager, augmented AI, AWS Marketplace. You have a lot of options that you can really see in Amazon SageMaker. Now, you can either do this project on Amazon SageMaker Studio, but we'll be creating this project on the Jupyter Notebook. So we'll be creating our first instance. You can just click on the drop down menu of Notebook and then click on the Notebook Instances option. And as you can already see, there's an instance that's currently running, which is named as Edureka Demo 16. Okay. And you can see there's a creation time, its status, and actions that you can currently take on it. So now we'll go ahead and create our own notebook instance. It's a pretty easy thing. You can just name your notebook instance anything you'd like. I'm just going to name it demo. Okay, you can pick a notebook instance type. You can also pick an elastic inference. I'm just going to let the instance type be ml.t2.medium. Okay, I'm just going to scroll down. So the IAM role is pretty interesting. So it is basically an AWS identity and access management entity with permissions to really make AWS service requests. Now, IAM roles cannot make direct requests to AWS services. They're basically just meant to be assumed by authorized entities such as IAM users, applications, or even, AWS services such as EC2. Okay. So what I'm going to do is I am going to create a new role here. So here the IAM role that you will create will provide access to the S3 buckets you specify. So for all of y'all who don't know what S3 buckets is, an Amazon S3 bucket is simply a public cloud storage resource that is available in AWS, which is simply termed as Simple Storage Service S3 and object storage offering. So basically it's very similar to, file folders or store objects. So S3 really just contains data and its descriptive metadata. So basically it's just like a database, okay? And now you can specify your S3 buckets that you'd like. So here I'm just going to pick any S3 bucket. Currently I have only one S3 bucket. So I'm just going to click on that and I'm going to create role. And you can see that there's a notification that says success, you created an IAM role. Once that is done, you're all set. You can go ahead and create your first notebook instance on Amazon SageMaker. So usually this takes some time before it creates. Right now the status is pending, as you can already see that. So once it's created, it'll just say the status is in service. So we'll just wait for it to get in service. Okay, now that you can see the status says in service, it'll take a while to get in service. Now there are two actions that you can perform. You can see that the first one is open Jupyter, or you also have an option where you can open Jupyter Lab. I'm just going to click open Jupyter, and you can see that the page is redirected. Now that you can see that, you'll be redirected to your first empty notebook, your Jupyter notebook. And here you can create your first file. And since we'll be creating a new notebook with Python 3, so I'm just going to click on that. See that your first, so you can see that your first file has been created, and you can name this whatever you'd like to. You can just name it demo, or you could just name it first project. Let's name it first project. And I'm just going to rename this. And if you want to save the file, you can just save and checkpoint. If you want to add cells, you can do that. If you want to remove cells, you can just click this scissor icon. You can also copy particular cells that you'd like to copy, and you can paste cells below too. If you want to move from one cell to another, you can use these arrow buttons to, switch up and down. If you want to, select and run a particular block of code, you can just press this button. If you want to interrupt the kernel, you can just press the pause button. If you want to restart the kernel, you can just press this refresh button. You can also restart the kernel and rerun the whole notebook. And you can also use this option for, specifying what kind of block you want to execute. If it's a code, you can just click code, and you can just print whatever you'd like. I'm just going to print hello. And once I execute it, it will give me the output hello. And if I want to add headings, I can do that too. And I'm just going to run this. And you can just print this as a heading. If you want to mark them down, you can mark them down too. And you have many options. You can really do a lot of things with this. And you can also see there's a navigation bar here. You can save your files. You can open a new notebook. You can open the previous files if you have any. You can make a copy. If you know how Jupyter Notebook really works, this is going to be a piece of cake for you. And also, you can view, you can insert, and you can also make manipulations with the cells that are currently present in your notebook. And there are a lot of options. You'll really get a hang of it once you start using Jupyter. Okay, now that we have an idea of how to create your first notebook instance, let's move on to the next part of the session. So what we're going to do first is we're going to download, explore, and transform a particular data set. So in this step, you load the adult census data to your notebook instance using the SHAP, that is the Shapley Additive Explanations Library. And we are also going to review the data set, transform it, and then upload it to Amazon S3. Okay. As you can already see, I have everything in place. So first, what we're going to do is we are going to install the SHAP library. Now, if the current Jupyter kernel does not have the SHAP library, install it by running the following conda command. That is conda install -c conda -forge SHAP. There's also a way to download SHAP on Jupyter Lab, and that's not necessary right now, so we're not going to discuss it. Now, if I go a little down to the next cell, now, if I scroll down a bit, you can see that using the SHAP library, I have imported the adult census dataset. So you can see that import SHAP. As you can see, I have two variables, X and Y, and also X display, Y display. And also I'm going to display all of the feature names. So you can see that in the output, we have 12 different feature names, and that's printed for us: age, work class, education number, marital status, occupation, relationship, race, sex, capital gain, capital loss, hours per week, and country. Okay. So the feature name is basically a list object, and it should list the features of this data set. And that's what the output shows us. So now if I scroll down a little more, you will just have to run the following script to display the statistical overview of the data set and histograms of the numeric features. You can see that the figure size is 20 by 10, and it's just describing the entire data set. That's all. You have a proper repeat. So you have a good overview of the data set. This is great. Now, if we scroll down a little more, we are now splitting the data set into train, validation, and test data sets. Okay. Now, using sklearn, we are splitting the data set into a training set and a test set. And the dataset is randomly sorted with the fixed random speed and 20% of it for test set. Now, moving on to the next block of code, you're splitting the training set to separate out a validation set. That is 75% of the training set really becomes the final training set, and the rest is the validation set. Okay. Now, moving on to the next block of code, we are using the pandas package. I'm sure everyone knows the pandas package. It's one of the most important package in Python. And here we're going to use it to explicitly align each data set by concatenating the numeric features with the true labels. Okay. Once that is done, we are just going to check if the data set is split and structured as expected. So I'm just going to print train, and it's going to give me the training data set. And I'm going to also print validation, and it's going to give me an overview of the validation data set. And finally, I am going to also display the test data set, and it's just going to give me an overview of that. You can see the number of rows and columns too that is specified in the bottom of each of these outputs. That's great. Now, moving on to the 10th block of code, we're going to convert the train and validation data sets to CSV files. This is really important. So we're going to use CSV format to store the data, and the first column is expected to definitely be the output column. Okay. Now we're going to convert the train and validation data frame objects to CSV files to match the input file format for the XGBoost algorithm. We're going to be using that algorithm. We'll come to that later. Moving on to the 11th block of code, we are finally going to upload the data sets to Amazon S3. This is really important. Now, using the SageMaker and Boto 3, we have to upload the training and validation data sets to the default Amazon S3 bucket. And the datasets in the S3 bucket will be used by a compute optimized SageMaker instance on Amazon EC2 for training. Now, the following code, what it does is it sets up the default S3 bucket URI for your current SageMaker session, and it creates this new demo SageMaker XGBoost adult income prediction folder, and then it uploads the training and validation datasets to the data subfolder. Okay, I hope this is clear. Moving on, we have to run the following AWS CLI to check if the CSV files are successfully uploaded to the S3 bucket. Okay, and it should return this following output. And you can see that the train CSV file and the validation CSV files are the outcome. That's great. And that's right. So let's move on to the next part of the session. So now what we're going to do is we're going to train our model. Okay. Now, to choose the right algorithm for your particular data set, you typically need to evaluate different models to really find the most suitable models for your data, right? Now, for simplicity, the SageMaker XGBoost algorithm, that is a built-in algorithm, is used throughout this tutorial without the pre-evaluation of models. Now, if you want SageMaker to find an appropriate model for your tabular data set, it is recommended to use Amazon SageMaker Autopilot that automates a machine learning solution. Okay. Now let's switch back to our demo part. Now, after you've finally figured out which model to use, you can start constructing a SageMaker estimator for training. Now, here currently we're using the XGBoost built-in algorithm for the SageMaker generic estimator. So the first thing you have to do is you will have to run a model training job. So for that, you will have to import, you can see in the block 13, you will import the Amazon SageMaker Python SDK and start by retrieving the basic information from your current SageMaker session. Okay. And this returns two following information. The first one is the AWS region, the current AWS region where the SageMaker notebook instance is running. Currently, you can see that it's running in US East 2 region. And there's also another output that we have, that is the role. And this is the IMA role used by the notebook instance that we created, if you remember. Okay. Now, I just checked the SageMaker Python SDK version by running this command, that is SageMaker __version __. And this is because I wanted to know the version of SageMaker. If the SageMaker version is less than 2.20, then you will have to update it. Okay. You can update it by using !pip install -q uppercase U SageMaker. But if you have a version of SageMaker that is above 2.20, then you're good to go. Okay. Moving on to the next block of code. Now we're going to create an XGBoost estimator using the SageMaker.estimator.estimator class. Now, in the following example code, the XGBoost estimator is named XGB_model. Okay. So we have used the name XGB model. Okay. So I hope that is clear. Now, to construct the SageMaker estimator, you'll have to specify some parameters, okay? You can see all of these parameters here. We're going to discuss about each of these. Now, the first one is the image underscore URI, which specifies the training container image URI. Now, in this example, the SageMaker XGBoost training container URI is specified by using the command SageMaker dot image underscore URIS dot retrieve. Okay. And the role that we've specified here is the AWS identity and access management role that SageMaker uses to perform tasks on your behalf. Now, for example, reading training results, call model artifacts from Amazon S3, and writing, training results to Amazon S3. All of this is performed by the access management role. Okay. Now, the train instance count and train instance type is the type and number of Amazon EC2 ML compute instances to use for model training. Now, for this training exercise, you use an ml.m2.medium instance. Okay. And you can use anything you'd like to. Then moving on to the train volume size. This is simply just the size in GB of the EBS storage volume to attach to the training instance. And this must definitely be large enough to store training data if you use file mode. Okay, file mode is on by default, so you don't really have to worry about that. Okay, moving on to the output path. Now, the output path is simply the path to the S3 bucket where SageMaker stores the model artifact and training results. SageMaker session, on the other hand, is the session object that manages interactions with SageMaker API operations and other AWS services that the training job uses. Rules, finally, is the last parameter, and it specifies a list of SageMaker debugger built-in rules. Now, in this example, we have used the create XGBoost report, which creates an XGBoost report that provides insights into the training progress and results. And we will check this report out later. Now, if we move to the next part of the code, we can see that we have set the hyperparameters for the XGBoost algorithm by calling the setHyperParameters function, by calling the setHyperParameters method of the estimator. And there's a complete list of XGBoost hyperparameters. You can also tune the hyperparameters using the SageMaker hyperparameter optimization features. Okay, moving on to the next block of code. So here you can see that we're using the training input class to configure a data input flow for training. Now, the following code shows how to configure training input objects to use the training and validation datasets you uploaded to Amazon S3 in the split the dataset into train, validation, and test dataset section. Okay. Now, once we've configured that, so in the next block of code, we're finally going to train the model. So here we're going to call the estimator's fit method with the training and validation datasets. Now, by setting weight is equal to true, the fit method displays progress logs and also waits until training is complete. And once the training is done, you can see that the output is completed, training job completed, training seconds, and the billable seconds is given. Okay. Now, in the next block of code, we run the following code to specify the S3 bucket URI, where the debugger training reports are generated and checks if the reports exist. Okay. Now, in the next block of code, you will have to download the debugger XGBoost training and profiling reports to the current workspace. Then you'll have to run the following IPython script to get the file link of the XGBoost training report. Okay. Now, the following IPath script returns the file link of the debugger profiling report that really shows summaries and details of the EC2 instance, resource utilization, system bottleneck detection results, and also the Python operation profiling results. So once you run this particular block of code, you can just click below to view the profiler report. And as I've already mentioned, here you can just see all of the resource utilization, the bottleneck detection results, and all of the, really just a summary and statistics of the report. So here you have the rule summary where you can see the GPU memory increase, the CPU bottleneck, the max initialization time, the low GPU utilization, load balancing, etc., etc. You have a lot of things that are happening here. You can see the start time, the end time, the job duration, that's 56 seconds. Okay, let's move back. Now what we're going to do is we are going to get predictions, deploy our model to Amazon EC2 using Amazon SageMaker. Okay. Now, to host a model through Amazon EC2 using Amazon SageMaker, you will have to deploy the model that you trained in create and run a training job by calling the deploy method of the XGB model estimator. If you remember, we had declared the XGB model in the previous session. Okay. Now, when you call the deploy model, you must specify the number and type of EC2 ML instances that you want to use for hosting an endpoint. Okay, so you can see that we've used three different parameters here. The first one is the initial instance count, that is the int, the number of instances to deploy the model. The second parameter is the instance type, which is string, the type of instances that you want to operate your deployed model. And the last parameter is the serializer, which is int2, and it serializes input data of various formats, that is a NumPy array, list, file, or buffer, to a CSV formatted string. And we can use this because the XGBoost algorithm accepts input files in CSV format. Now, what the deploy method really does is it creates a deployable model and configures the SageMaker hosting services endpoint and eventually launches the endpoint to host the model. Now, we will have to retrieve the name of endpoint that was generated by this deploy method. Okay, so for that, we will have to run the following code, that is the xgb predictor.endpoint_name. Now, this should return the endpoint name of the XGB predictor, and the format of the endpoint name is SageMaker XGBoost and the date, that is in years, and the month, the date, the hour, and the seconds, the minutes, the seconds, everything. Okay, so the deployment of model was pretty easy, right? Now let's move on to the next part of the session. Now that we have trained and deployed a model using Amazon SageMaker, evaluate the model to ensure that it generates accurate predictions on new data. Okay. Now, to evaluate the model and use it in production, we have to invoke the endpoint with the test dataset and check whether the inferences you get returns a target accuracy you want to achieve. So in the 27th block of code, you set up the following function to predict each line of the test data. Here you can see in the code, the rows argument is to specify the number of lines to predict at a time. Then you can change the value of it to perform a batch inference that fully utilizes the instance's hardware resources. And in the next block of code, you run the following code to make predictions of the test data sets, and then you plot a histogram. So for obviously plotting histograms, we have to use matplotlib.pyplot, and it will display the histogram. Now, in the next block of code, the predicted values are float type. To determine true or false based on the float values, you need to set a cutoff value. You can see that we've used the scikit-learn library to return the output confusion metrics and classification report with a cutoff of 0.5. Once that is done, the output will return the following confusion matrix. Okay. Now, to find the best cutoff with the given test set, compute the log loss function of the logistic regression. Now, the log loss function is defined as the negative log likelihood of a logistic model that returns prediction probabilities for its ground truth levels. Now, the code numerically and iteratively calculates the log loss values. It returns a log loss versus cutoff graph. You can see that output here. So this is the log loss curve. Okay. Now, finally, we find the minimum points of the error curve using the NumPy augmin and min functions. So this should easily return log loss is minimized at a cutoff of 0.53, and the log loss value at the minimum is 4.34, and so on. Now, instead of computing and minimizing the log loss function, you can estimate a cost function as an alternative. For example, if you want to train a model to perform a binary classification for a business problem, such as a customer churn prediction problem, you can simply set weights to the elements of confusion matrix and calculate the cost function accordingly. I hope this demo section proved and helped you. Let's move on and check out the case study. So in the Amazon SageMaker case study, we'll be talking about Grammarly. Now, everyday Grammarly's algorithms help millions of people communicate more effectively by offering writing assistance on multiple platforms across devices, and also through a combination of natural language processing and also advanced machine learning technologies. Amazon SageMaker makes it possible for Grammarly to develop their TensorFlow models in a distributed training environment. Here, workflows also integrate with Amazon EMR for pre-processing, so they can get the data from Amazon S3 filtered with EMR and Spark from a Jupyter notebook, and then eventually train in Amazon SageMaker with the same notebook. SageMaker is also flexible for their production requirements. They can run inferences on SageMaker itself, or if they need just the model, They can download it from S3 and run inferences for their mobile device implementation for iOS and Android customers. So this is how interesting and how helpful Amazon SageMaker is in today's world. With this, we come to the end of today's session on how to deploy a machine learning model with the help of Amazon SageMaker. If you have any queries, leave them in the comment section below and we'll get back to you as soon as possible. Until next time, thank you.